Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be talking about the behavior of a function near its asymptotes. If you have any questions about this problem, please feel free to put them in the comments below. Or if you have an additional question or a problem that you'd like to see done, feel free to put them down there as well. So let's jump into this problem. So we have this function, x squared minus 3x minus 5 divided by x minus 2, and we're asked to find the asymptotes of this function. So when we want to find the asymptotes of a function, we need to look at both the denominator, specifically the factors in the denominator that won't be canceled, and then the behavior when x goes off to infinity or to negative infinity. So looking at this function, there's no way to factor the numerator. There's no factors of -5 that will add up to -3. So there's no chance to cancel x minus 2. So what we want to look at now is what is the limit as x approaches 2? What is the limit of f of x as x approaches 2? So we're going to consider the limit as x approaches 2 of f of x. Now, because of the way it works, we're going to need to look at both the left hand and the right hand limits for this. So we'll take the limit as x approaches 2 from the left of x squared minus 3x minus 5 over x minus 2. And if we take numbers suitably close to 2 on the left, so if we take x equals 1.99, let's say, then f of x is going to give us a value. That gives us 700.99, so it's positive. So we can say that the limit then is going off to positive infinity. On the other side, we're going to take the limit as x approaches 2 from the right. So we can just take a number on the right of 2, like 2.01, and then evaluate the function at 2.01. So this ends up being negative 698.99, which tells us that the limit as x approaches 2 from the right is negative infinity. So at 2, then we get this divergent behavior. Since one side is going out to positive infinity and one is going out to negative infinity, we say that the limit as x approaches 2 is divergent. It does not exist, you can say as well, because it goes off to both positive and negative infinity. For our other asymptotes, we want to consider the limit as x goes off to positive infinity. And we'll do the same for negative infinity. There's a couple of ways of doing this. The commonly accepted method is to divide the numerator and the denominator by the largest power in the denominator. And that's x to the 1. So we're going to divide the top and the bottom by x. And when we do that, we get the limit as x approaches infinity of x minus 3 minus 5 over x all over 1 minus 2 over x. So we know that the limit as x goes to infinity of any constant over x is going to be 0. In fact, we can say x to some positive number p down here. So anytime we see that in our limit, we know that that's going to go to 0. So what that tells us here is that this is going to go to 0 and this is going to go to 0, but this right here is going to go to positive infinity. So we're going to say that the limit as x goes to infinity of our function is equal to positive infinity. So let's look at the last one, which is going to be the limit as x approaches negative infinity. So doing the same thing, we're going to multiply the top and the bottom by 1 over x, divide top and bottom by x, essentially. And we get the same result. x minus 3 minus 5 over x all over 1 minus 2 over x. So this time around, we're going off to negative infinity, and still 5 over x and 2 over x, those will both go to 0. So that leaves us with the x minus 3. And since we're going off to negative infinity, that will end up being negative infinity. So since the function as x approaches positive or negative infinity goes off to positive and negative infinity, there is no horizontal asymptote. So there's no horizontal asymptote for the function. So that's it. That does it for our problem. All right, thanks for watching, and I'll see you in the next video.